It's time for physics! Baseball, a sport which surprisingly has a lot of physics in it. Have you ever watched a game of baseball and considered the physics that make it happen? Let's look at pitching. There are many aspects to pitching that have to do with forces, motion, and angles of applied forces. By utilizing physics, pitchers are able to throw over 90 miles an hour. Today, we're going to take a look at the physics of pitching. Since we don't have an actual major leaguer today, we're just gonna use this guy. Here, the pitcher is in the load-up position. A good load-up is necessary for a fast pitch because the weight put on the pitcher's back leg will help generate the force that puts velocity behind the ball. At this step, the pitcher has as much weight on his back leg as possible. He is about to transfer his weight onto his front leg. This weight transfer will create a forward motion and a forward force of the pitcher's arm. This creates a high amount of velocity on the ball. And the release. The pitcher releases the ball, but must remember to keep his forward momentum going. If he doesn't, there will be a disruption in the momentum which will lower the velocity of the ball and he will suck. And that's pretty much all you need to know about physics and pitching. Disappointed? Too bad. I'm Ron Burgundy. The popular topic of today, can you defy gravity? Is it possible to defy gravity? That's what the popular debate of nowadays is. I'm here with my co-host.
Hi, I'm Madame Curie.
And we're going to be talking about this very topic today. Now, I believe you can defy gravity. Humanly possible. If you set your mind to it, you can do it. What are your thoughts?
Honestly, I think you are a complete idiot, and I don't think you deserve this job.
Well, hear me out. So, if you were to let's say you jump out of a plane, and your parachute goes wrong. You know, it just completely doesn't work.
If you die.
No, you don't, because here's what happens. You're falling from the air. If you really if you take your brain, you take your nerves in the brain, and really focus yourself on feeling the wavelengths in the air, you could maneuver your arms and do a swinging motion with your legs to try, and you could, just dance in the, the group. You can maneuver the air in the air to try and to stabilize yourself, and then you would actually have the reverse effect and go back up.
Did you tell the nice men in the white jackets that when they took you away?
No, hear me out. So you would go up.
Yes.
So you wouldn't even need a parachute, because if you embrace your telekinetic powers. So
you're Professor X.
No, well, professors, I don't know. You could be Professor X if you wanted to. But another example. Let's say in a car you were falling off a cliff, right? And you're going right off a cliff. If you were to go fast enough and spin the wheel in a certain way, you could possibly be able to tilt the car upwards. And then if you accelerate fast enough, you'd be able to actually fly through the air and land safely on another side of the cliff. If you were to hit the pedal and accelerate, it could happen. I'm telling you.
Okay. What's next to discuss?
Well, next, we're gonna do a short commercial break, and on this commercial break, we're gonna show you a new film that's actually talking about gravity. It's called Epoch of Physics, and it's coming out in theaters very soon. So go take a look. I'm Ron Burgundy with
Madame Curie,
and we'll see you in a bit. This just in. The forces of the earth are at war. I repeat, the forces of the earth are at war. What a lovely day. Oh, what the?
find the D. Find the D, children. Millimeters, please. Millimeters.